Let's focus on the problem Shafina and swap. So you are given a number n, sequences 1 to n. You choose two elements and swap them. So swap is nice if there is an integer m such that some of the first m elements. Okay. So basically you can make exactly one swap, and after the swap the sum of the first m elements should be equal to the like half of the entire sum, and same as the last n minus m elements. Okay, you are given the test cases. For each you are just given and that's it. You have to print out output the number of nice swaps. Okay, so t is 10 raised to 6, so we might be expecting what, like a constant or some logarithmic solution. 2 seconds. Okay, let's see. Okay, so for n equal to 1, it's 0. Reason being sum is 1, you can't do anything. You can't really divide them in halves. For 2, it's 1 plus 2, 3, nothing. For 3, it's 1 plus 2 plus 3. So consider the sequence 1, 2, 3. You can swap 1 and 2, and sum will still be like 3 on each side. You can swap 1 and 3. Then like for just the first element, sum will be 3, and remaining 2 will be 3 again. That's it, right? You can't swap 2 and 3. So answer is 2. Okay. So what? 1, 2, 3, 4. 4, 5, 6, 7, 8, 9, 10. Sum is 10. I need to create 5. So 1. I will bring 4 over here. Yes, I can do that. 1 plus 2 plus 3. I can't bring 1. So yeah. So 4 can come over here. Similarly, 1 can go over here. And again, it will be this. Hmm. So 1 is swapped with 3 and 2 is swapped with 4. Let's see 5. So for 5, sum is like 4, 5, 7, 8, 9, 10, 15. So can't divide by 2. For 6, that's like uh, 4, 5, 6, 7, 8, 9, 10, 15, 15, 6, 21. Won't happen. 28. Sum equal to 28. And so I need to create 14, right? So 1, 2, 3, 6, 7, 8, 9, 10, not 15. Okay, 10, 4. So I already have 10. I need to create 14. So basically I need 4 more. How can I get 4 more? I can swap 1 with 5. So what does it look? 5, 6, 7, 8, 9, 10, 11, 14. Or I can swap 2 with 6, or I can swap 3 with 7. And that's it. Right? Makes sense. Okay. So basically what I am trying to do over here is that let's say take like first m elements whose sum is just less than this. Is it? Then what would happen if I just take 3? So like 3, 4, 5, and then I swap 7 with 1. That's like 7, 8, 9, 10, 11, 12, just 12, right? Okay, let's try to have some maths. So 1 till m. So let's say these are the first m elements, and then up till n. So this is the entire sequence. Now, what I want to do, I want to swap exactly once. I have to swap once, right? Yeah. So I have to swap them exactly once. So let's say I choose. So if I swap just like one element from here and like just over here, like if I swap some elements which are in the first m elements within themselves, the sum won't really change. So it can be like m. So sum of first m element is mn plus 1 by 2. If this is exactly equal to n into n plus 1 by 4, like half of the sum of n natural numbers. So if that's the case, um, I can just pick any of the two, like any of these two, and any of these two, or and I can swap. So my answer will be something like MC2 plus n minus MC2. I can swap any of the pairs among this, if that's the case. Uh, Otherwise, what I will end up doing is m multiply by m plus 1 by 2. I will, let's say, remove some element in the first m elements, and I will add, sorry, and I will swap it with some element, let's say y, which is from m plus 1 up till m. So my sum will be this minus x plus y minus x. This will be equal to this. Also, y minus x should be greater than or equal to 1. Only then I can swap, and it won't be greater than n minus 1. So this will be less than equal to n minus 1. Given n, this will be constant, and we will just have a quadratic equation for m. Similarly for this and this, the second unknown is y minus x. So let us say d is equal to y minus x. So let me just replace it with this and this and this. So over unknowns in this is m and d. Let's try to solve these two separately. So this says like m into m plus m uh, by 2 minus n into n plus n by 4 is equal to 0. Only for that answer will be this. Um, and obviously m needs to be integral. Okay, so let me just multiply everything by 2. So this becomes, yeah. So for the solution of this particular quadratic equation, m square plus m minus this, if I have an integral solution, integral positive solution, then I will have this particular value. So let me actually make um, maybe so let me actually make a method which solves uh, quadratic equation. So double A, double B, double C. I'm thinking like a generic thing like A. I'm trying to solve A x square plus B x plus C is equal to 0. Solution for this, like we introduce a variable D, which is B square minus 4 into A into C. If D is less than 0, then I simply return -1, negative. Okay, so m should never be negative, right? So let me return -1. I will just check if uh, this thing d, sorry, return -1, right? Yeah. So I'm saying it such a way that if solve value of this is negative, I'll simply ignore that. That is, it is impossible. Impossible. Otherwise, uh, let's say d is double val is equal to square root of d minus b plus minus. Wait. So what about b? It's like m square plus m over here. So always it will be m square plus m, something like that. So b will be always plus 1. So minus b is -1. So in fact, I will ignore the negative term altogether. The solution is minus b plus minus under root of d divided by 2a. So because like this is already negative and this will be a positive value, I will just pick up the positive thing. I do not need to care about the negative thing. Uh, Minus b plus minus the root b square minus 4ac divided by 2 into a, and then I simply return value. But let me add this as well. So int n, I will kind of have input over here, and I will check if m is strictly less than 1, I have to do some epsilon thing, right? So in doubles, like you can't really compare it with integers directly. You have to keep some epsilon because like so double 3.0 will not really be stored as 3.0. It will be stored as 2.9999999, something like that. So that's why we need to have some very infinitely small value. So let me say EPS is equal to, I don't know, we generally use epsilon. That's the generally competitive norm. So I'm just using the same thing. EPS is equal to, let's say, 1e minus 9. So m, so if this plus EPS, if even after adding this, it becomes like 3.000, sorry, if it's 0.999, uh, let me take it as m, plus epsilon, if it is still less than less than 1, then I will say m is equal to -1, else if m is strictly greater than uh, m plus, sorry, m minus EPS is strictly greater than n, I will say again it is impossible. So minus over here because of this, like this is greater, right? So even for values like let's say n is equal to 100, 100.00001 would be equal to n. So I have to ignore only those which is greater than n. So that's why I will allow minus uh, this, and finally m. So I will kind of get an answer for this, and I will see whether this is an integer over here or not for this particular scenario. So let me start implementing this as well. So double m1 is equal to, I will try to solve for what? A is 1, B is 1, and C, right? So int 64C1 is equal to n. In fact, let me make this as int 64 as well, just to avoid the overflow things. So n minus of n into n plus n by 2, right? Yeah, that's exactly true. So this is like C1. I will try to solve for this. If just to make sure like this is integral, uh, let me do this. That in 64, m1 is equal to, let's say, floor of this again plus EPS. And just kind of like I will double check this equation so that there is not any issue with the double things. So like this should be 0. So I'm just kind of verifying that. So if m1 is greater than 0 and m into m, this thing, m into m plus m plus c1 is equal to 0. Only then I have some answer. So let's say in 64 answer 0 is m1. Answer plus is equal to m into m minus 1 by 2 and answer plus n minus m. So for the first m, I can pick anything. So there's a number of ways to pick a pair in the first m elements. I kind of like swap amongst anyone, and the sum will still remain same. Now I can also pick any pair in the remaining n minus m elements and pick any pair, and that should also work fine. So answer is this. So any contribution due to this particular equation will be handled over here. This should be in 64, right? What's the issue? So temp is equal to solve 1 comma 1 comma C1 plus EPS. Again, like I'm taking floor, so I'm just adding EPS and I'm just verifying if the answer is fine or not. So this should be good enough. Let's try verifying. Okay, let's try input from a file. Maybe let's say 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's start. And then simply see out answer. Zero, one. Okay, so for 2, we have a contribution like this, right? Yeah, that's true. So for example, for uh, 1, 2, 3, 1, 2, for n equal to 3, uh, uh, m is like just m equal to 2, and you can actually swap like 1 and 2 over here. And for 3, you could have done that. I think there is one more, but yeah, overall this looks good. Second contribution can be from these three equations. So let me try updating like d and just trying to solve for this m. So this implies m plus d minus this is equal to 0. Now I having equality d is greater than 1. So if I replace this with 1, like everything will be less than 1, less than 0. Or in other words, like maybe let's put it like this: d is equal to uh, this minus this. Now d is greater than or equal to 1. This implies uh, for t greater than or equal to 1, this is greater than or equal to 1. This implies this plus 1 minus this uh, is less than or equal to 0. Goes in. So this implies this, I'm multiplying each term by 2 minus this entire thing by 2 is less than or equal to 0. Similarly, for d is less than or equal to m, this will be less than or equal to n minus 1. So this will be greater than equal to, and instead of this it will be n minus 1, so 2 into n minus 1. So these are the two quadratic equations which I am trying to solve. So I will try to find m for this and then m for this, and let's see what are the different values. What can be the range? I think maybe like we can try putting the maximum value like 10 to the 9 and see. Reason being, the final m will be minus b uh, over here. That's like 2n minus under root of n square, which will be approximately n. So n minus n gets cancelled. So this should be comparatively a constant value, very less overall. Yeah, let's try figuring this value out. So first, let's try to solve for this particular problem, this particular equation. So uh, int 64 m2 is equal to this should be less than equal to, right? So floor of this, uh, let's keep the same format. So temp is equal to m square, b is 1 as well, and c is a little different. C is 2 plus, this is actually just c1, right? So let me reuse this. There's nothing but n into n plus n. Yeah. So this is 2 plus c1. I'll try to solve for this. And because I'm taking EPS, I'm just taking a floor, I'll just take EPS. Similarly, let's try to solve this particular equation. Over here, 1, 1, and 2 into n minus 1. Again, it's plus c1. Now over here, I have, this is greater than or equal to 0, right? So that means I have to take a seal. So what I'm saying is, let's say m comes out to be 0.5, I have to take just 1. So thus it will be minus EPS. Let's call it M3, C out M2, M3. Let's try to add one more use case, let's say 30. 1, and this can be 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for 1 and 2, I'm getting -1, -1. In fact, let me hard code that. So if n is less than equal to 2, see out 0 and simply return 1, 5, 6. 12 and 13 this. Interesting. So for even for 10 to the power 9, like I'm just getting two values for m, n3 and m2. So let's do this eh, for m is equal to m3. M3 is less, right? Yeah. M is less than equal to m2, m plus plus. Now for each m, I have to do something, which is I have to try to find d. So d will be something like this. N64d is equal to n into n plus n by 4 minus m into m plus m by 2. So I find the value of d. What I have to do is, so d is like y minus x. So let's talk about y. What is the maximum value of y? It can be m plus d, or it will be n, like whichever is smaller. So like I'm trying to figure out like given a particular d, what are the different number of ways I can pick x and y. So that will be nothing but different possibilities, different distinct values of y, because if y exists, x will always exist, like just y minus d. In fact, I have to make sure that x does not go below 1 as well. So uh, it will be minimum of n comma m plus d minus, and what is the minimum value of y? It can be either m plus 1, or it will be 1 plus d. So if m plus 1 minus d is less than 1, so for example m is 2 and d is 10, I can't really make y as 3 m plus 1, because like x will be negative, and x value should definitely be greater than or equal to 1. So it will be this max of this comma 1 plus d plus 1. So this is the general trick, like the maximum value minus minimum value plus 1. It gives all the possible ways of the figuring this value. Answer plus equal to this. And yeah, seems like it. Yeah, answer. So instead of printing answer earlier, I will just print over here. Let's try running this solution. 0, 0. So n equal to 0, n equal to 1, n equal to 2, n equal to 3, 4, 5, 6, 7. This is weird. Oh, I think I missed this. So for n equal to 5, sum is actually 15. So I can't really have exactly two, I can't really divide into two. So what I'm trying to say is the sum should be divisible by 2 at least for this solution to exist. So let's say in 64 sum is equal to n into n into n plus 1 by 2. Oh, it's actually just this. So if sum and 1, so if sum is odd, I'll just simply see out 0 and return right away. So 0022, 003, 004, this is 112. What is the value? Let me just trace C as well. Oh, sorry, N. So for n equal to 20, answer is coming out to be 112. It means like this will be something possible. Let me trace M1 as well. M1 comma M2 comma M3. Let's just double check this particular test case. So n equal to 20, M1 is 14. So like 14 into 14, 13 by 2, 13 into 7, it's like 91. And this is what? Uh, n n is 20, right? So 20 minus 13, that's 7. 7 into 6 by 2, 7 into 3, 7 3 is 21. This comes out to be 21. So 112 is coming out because of these. Okay, and what about these? Like the contribution is 0. Is it possible? Does that make sense? So M2 and M3 are 13. So like I am trying to figure out, let me just remove this and just keep one solution for 20. Yeah. So let's trace D as well. So D is coming out to be 14. D is 14, M is 14. Wait, M is 14? That's true. So what is the value of these? In T2, in T1 is, let's say this. So let's trace T1, T2, T1, T2. This is wrong, right? Like, what was the answer before this? Answer is 106, 9, 11. So one is 14. 14 into 13 by 2, that means 14 into 7. Sorry, 13 into 7, that becomes 91. This is 20 minus 14, that is 6 into 5 by 2. Oh, it's 6 into 5 by 2. It's like 15. Makes sense. So 106 and this 112. So overall, this looks fine. Yeah, let's try submitting. So my traces never really affect the overall output of the solution. Reason being, like I have like this for my local setup. So if it is defined, I have some definition of trace. Otherwise, it's just empty. Yes, that's it for the problem. Thank you.